Okay, so good morning, everyone. I guess we should just start. So in our previous class, we looked at Nodejs. It's fundamental design principles and the rest of that, which we look at the module systems. We look at other things like the architecture, the core architecture of Node.js and all of that. So today we'll proceed with core Node.js, but then we'll be looking at asynchronous control flow patterns in Node.js. And under asynchronous control flow patterns, we have callbacks, promises, async await, event emitter streams, and control flow libraries. So basically, we already know what callbacks are in our previous class, and we've treated promises and async await. So in order not to repeat ourselves, we move on to event emitter streams. And then control flow libraries, you can just research about that and get to understand, because they're all built on top of callbacks, promises, and async await. So it's just a kind of documentation stuff. You just read the documentation and you understand it better. Okay, so what I'm trying to say is basically today we'll be dealing with event emitters and streams. Okay, so we've been hearing about streams and event emitters. So what really are streams? Or should I say event emitters? Okay, we'll start with event emitters first before streams. Okay, so what are event emitters and how are they useful in Node.js? Okay, event emitters, these are basically a kind of let me say a kind of pattern in Node.js that emit event on when something occurs, it sends out event, or it waits for an event to occur and then send out an event. Okay, they are just crucial signals emitted by streams in Node.js to communicate their state and data flow. So understanding this event is essential for effectively working with streams and handling data asynchronously. So an event is basically just used in Node.js for communication. So they emit data based on their current state. So we have data event, which is the most fundamental event for readable streams. And it indicates that data is available to read from the stream. It indicates that data is available to read from the stream and all of that. So we have the readable event emitter class, and we have and the signals. So first of all, we start by exploring the concept of event emitters. Now, there are actually fundamental communication mechanism in Node.js for building applications that can react to events. So Sorry, I did not include the subtopics in our slide, but I will quickly try to mention them. And then, as I mentioned, I've not been feeling too well, but then I will try to update your docs so you can get all of these there. So the concepts, first of all, under events, we have the concepts. So we have the event, a signal that something has happened within the application. And we have the emitter. Number one is event, number two is emitter. Emitter is actually an object that can emit or trigger an event or trigger events. Then the listener. When an emitter emits an event, a listener is a function that is registered to be called when a specific event is emitted. Then we have event names, a string that identifies the type of event being emitted. Under the subtopics, under event emitters, we have the concepts, which we just discussed, and the call functionalities. We have event arguments, which are actually optional. So under call functionalities, we have emitting events. So using the emit method on an emitter object to trigger an event and notify registered listeners. So when you trigger an event, all the registered listeners get the events which is being triggered. Then listening to events, using the on or once method on an emitter object to register a listener function for a specific event. And also you can remove listeners using the off method to remove a previously registered listener. So we have also event arguments, which can optionally pass arguments to the listener's function, providing additional context about the event. We can also handle errors in event. Can consider proper handling mechanisms when working with event emitters, especially for unexpected events or errors within listener functions. And the common use cases for event emitters is to implement real-time communication features like chat applications. You can also coordinate tasks between different parts of your application, and then building modular and reusable components and can communicate through events. Like you can have the node schedule. You also have node cron. Those are the libraries for events and all of that. I recently used node schedule in one of production grade application I'm building. And we have the event emitter class. Nodejs provide a built-in event emitter class that you can inherit from to create custom emitters with event handling functionalities. We'll see to that in a bit. And we have popular third-party event emitters. Even though we have the built-in event emitter, it's widely used. We still have library like Event Emitter 3, which offer additional features and enhancements and make things more easier for you. We can also look at the best practices. Use descriptive event names that can clearly convey the meaning of the event. Organize your event listeners to avoid clustering your code, and then consider using event object arguments to provide context to listeners. So under the concept, as I earlier mentioned, we have events and signals, and we have emitters and listeners. So in events and signals, imagine your Node.js application is a kind of a city. So events are like signals or happenings within the city. So these signals could be anything from user clicking a button to a database operation completing or any other thing you can imagine. Now, event emitters and listeners. Okay, in that city, you can think of event emitters as the city's communication hubs. So this object can trigger or emit events to notify other parts of the application. So listeners are like the city residents who are interested in specific events. So they register themselves with the emitter to be notified when those events occur. So the emitters emit the events and the listeners get the events where they are being emitted. So we also have event names. Events are identified by unique names, which are in form of strings that describe what's happening. For example, an event name could be user clicked a button or a user has deleted his account or database operation complete or all of that. So another simple example we can look at is a kind of, let's say, imagine a shopping mall that is an emitter with a security system, which is an event. So when a sensor detects motion, that is the event trigger, the security system emits an intrusion detected event. So shops in the mall, those are the listeners, can register to listen for this event. Upon receiving this event notification, shops might activate their alarm systems. That is a listener function as a response. So moving on, we have the core functionalities. Now we'll now look at how we can emit events. So this emitting event involves triggering an event from an emitter object to notify registered listeners. So the emit method is used for this purpose. It takes the event name as a first argument and optional argument, that is the data, as additional parameters. So I think we should just practicalize this to understand what actually is going on under the hood. Oops. Okay, so we should just practicalize this to understand what actually is going on under the hood. And now we'll just import our event emitter class and then try to use the methods on the event emitter class. So first of all, what we do is let me zoom in a bit. Okay, I think this is okay. Let me just drag this down. Okay, const emitter is equal to new event emitter. Okay. It's equal to new event emitter. Okay, so now we can say, so let's emit a const so let us say emitter dot emit let's see message received. Then we can even pass the content, like let's say the content is let's see, hello from the emitter, like this. Now we can come here and do something like, so now that we have emitted an event, we've now emitted an event with the content. Here is the name of the event, and here is the content of the event. So listeners are functions that are executed when a specific event is emitted. So you use the on or once method on an emitter object to register a listener function. So on, the listener function will be called whenever the specified event is emitted, when you use the on listener. It will be called whenever the specific event is emitted. So the listener remains registered until explicitly removed. So the once listener function will be called only the first time the specified event is emitted. It automatically removes itself after the first invocation. So for instance, we can listen to this event by saying emitter dot on. Then what is the name? The name is, you can actually, you can say emit const event name is equal to message received. So you can just pass in the event name and then say on event name, it will take in a callback function of the message which we'll be receiving from the event. So we'll say message. And in here we'll say log. What are we logging? Let's say received or message received, like this. And then we'll say message. Okay, so this is supposed to be curly braces and not square brackets. So, okay, let's hope we don't get a cabri. Okay, event emitter is not defined. Okay, but okay, so I guess I'm supposed to import this off. This is off my head. Okay. From event, I guess. Okay, let's say node. Node events, I guess. Using the spelling. Okay, okay, okay. Okay, Obi, I'm see. What don't you understand? Seems so. Why aren't we getting anything here? Let's make sure this is aha. Okay, events. Let's just see. Just to be sure with what you are doing. Okay, okay, emit. Let's cross check that, please. Node. Node events, not emitter. Simply say events of node events like so. Okay, so now let's so I guess why are we not getting any anything in our console? Okay, message content. Okay, node index, and this is index.js. Let's make sure everything is in order. Okay, we have hello here, but here then we don't have. Okay, emitter emits. Okay. So what are you saying like this? Okay. Thank you so much for that. What's your name again? Toby, thank you so much for that. It's actually a mistake from me. Okay, so now we now have our, okay, as for Timothy, let me try to clarify. Is it Timothy or Obi? Okay, Obi. The thing here is, it's not emitter, it's node event. So this is actually a class. So we inherit, we evoke the class and then we get access to the method and properties. And one of the method is on, and the next one is emit. So when we emit an event, we actually listen to that event. So when we listen to that event, we get the message from the event. And this message here is actually an object. So if we remove the content, we have our message as content hello from the emitter. Okay, so now we can change our event name to, let's say, send message, and then we can bring in our event name here and event name here. Then we run our code again, then we have the same result. But by the time you change this thing here to another thing, let's say we change this to send message without the last E, get nothing. Because this here is different from this one. So we're listening to a different event, not the one emitted by this send message. So if you add our E here and run it, we have the same result because this name is the same as this. So that serves as our key. That is the event name. So we can listen to those events. So you can actually remove events. So now the listener on is a listener. Why this emit is the emitter. It emits this event. Then this we use this on method to actually get access to the event, to subscribe to the event. Now you can even do something like emitter once, and then you say event name, and here there is a callback, say message log message, like so. And then copy this one here, bring it down here, copy this as well, bring it down here, bring it down here, and then let's clear our terminal and run our code once more. Have message received. Okay, emitter once, then a constant log message. This is supposed to be called once. But then, okay, we'll get to that in a bit. First of all, let's look at how we can remove events. Okay, so let's look at how we can remove events. Let's say, we first of all write a function. We say function, and then we give it a name of, let's say, listener to remove. And then we pass in this message. And inside of this function, we say just log a message, say message like this. Now, on this listener, we'll come down here on the on. Let's take this one. Okay, functions are hosted, so let's leave it there. Then we'll come here and we'll say, and just say listener remove like this. And then after that, we can remove this. We'll say emitter dot off. That's to remove the event, and the event remove, and then the listener we want to remove like this. So this has been removed. The first time we call this, we register this this listener, and then after we are done listening to it, we've removed it. So we also have event arguments. As we mentioned earlier, events can optionally pass argument to the listener function. So this argument provides additional context about the event. Now in the emit method, you can specify any data you want to send along with the event name. So the listener function receives this argument when it's called. Okay, you can specify any data you want to send in the event, and then it will be received. Let's say the content here, and in here we can say, okay, let's say we have constant message is equal to title, new message, content, KodeCamp is fire, like this. Then we can, okay, it's fire, not if. We can come down here and pass in our message like this, and then try to log it to the console. Now we have the complete object here. Then we can destructure this and then say message content. Oops, okay, event here, message content, message received, okay, message content, like this, not here. We have message received, KodeCamp is fire. And then we can actually do something like equal to message. Like this, we can destructure it by saying content title. And we're destructuring this from the message, right? Like this. Oh, okay. Here is supposed to be an object with content title. Let's, oh, it's messing around with my head. Okay, so we can do something like const content title is equal to message, and then we can bring that down here. Then log it to the console, and we have our result content like this. And we can only do something like just title. We see message received, new message. Okay, so this is basically how we can work with events. You can destructure it right up here and then do whatever you want to do with it. And it's also essential to handle errors. So we just talked about arguments, how we can add arguments here. Now this here, we specify here this data, and then we send it along with this emitter. So this can actually, our listener can get access to this data and make use of it. Okay. So now, benefits, what are the benefits of event arguments? So event arguments they provide a richer context. Event arguments allow you to provide more information about the event, enabling listeners to make informed decisions and take appropriate actions. It comes with also flexibility. You can customize the data you send with each event, making your communication system more adaptable to different scenarios. And code reusability. By using event arguments, you can create generic listener functions that can handle events with varying data structures, improving code reusability. So as we've already seen how we can send arguments with events and all of that. So error handling, you can actually handle errors with events. You can do something like events, emit, try, catch. And here you have your event this, and here you see you log your error to the console. And you say error like this. Now let's change this here to a name we don't know. Okay, reference error. Event name is not defined. So when we look at our file here, look at index.js 2616. Let's see error like this. And then we have error, reference error. So this is what I want you to know, but this error is handled right here. Now let's remove this and then bring it up here and then run it again. Now, reference error, event name is not defined. There's 2414. Actually, the error is handled, but not here. So we don't have anything to do with the error. But if we have this handled properly, let's say we have this in here, we can actually throw new error and error occurred or something like that. So we now have control over our error. And what we have to do is error and error occurred. As simple as that. As you can see, it is handled on line 28 column 9 here, right here, column 9. Okay, that's great. That's basically how we can handle errors. And in here, we can do something like, in this function here, we can do something like, we can take this off, and we can say try, catch, this on message. Here, we want to listen to this, but on catch, you can see throw new error, something went wrong, like so. And in here, you can say log message or anything. We can process the event data or anything at all. Now, let's change this back to event name. Log this to the console. We have message received, new message. And in here, where we're handling errors, something went wrong. Let's say message, and then do this. Okay. Let's see. I'm trying to actually trigger an error here. Since this should trigger an error. Okay. Reference error leads to listener to remove is not defined. And look at where the error is occurring. Here on line 12, because of this function, listener to is not defined. Okay. And that's, we are not capturing it here. But this is basically how to, this error is occurring here and not here, because I want to trigger an error here that we can actually handle down here. You cancel like something like this. think everything is. But this is basically how to handle errors. Since I can't find a way to trigger a necessary error there, that's just it. So following the best practices, always handle errors within listener functions, especially if they involve critical operations or might throw errors due to invalid data. So this is basically the main place to always handle errors. So you consider using a centralized error logging mechanism to capture and track errors related to events emitters. And in some cases, you might even want to emit a separate error event if a listener function encounters an error. So notifying other parts of your applications. So what are the common use cases for event emitters? So they're actually versatile to Node.js for building applications that require communication and coordination between different parts. So some common use cases are real-time communication. They are ideal for building real-time features like chat application or collaborative editing tools. The server acts as the event emitter, triggering events like new message or document change or all of that. So connected clients, that is the web browsers, act as listeners, registering functions to be called when these events actually occur. So task queues and worker management. Most of us who know about building applications with microservices, we have different services, which are different servers. Let me put it like that so you can understand. We have different servers communicating together. So if we have a server built with Java, another built with Python, and another built with JavaScript, how do they communicate? So that is where task queues and worker management, all of those comes in. You can leverage event emitters and tools like RabbitMQ and Kafka. You can check out what RabbitMQ is. It's a message queue, and it's helpful in building microservices. So all those, they leverage event emitters to manage asynchronous tasks and worker processes. So a task queue event emits event whenever a new task is added. Then worker processes act as listeners, waiting for a new task event. So upon receiving the event, a worker can pick up the task and process it, ensuring efficient task execution and load balancing. So I guess I should I say Rabbit MQ? Rabbit MQ. So I just want to show you something here quickly. So here, this is sending a message. They've emitted a message here of hello. This message is emitted. They create a channel and emit a message, channel, circle, and then the message is received. This one here receives the message. The queue is hello. So it uses this queue to receive this message. And up here, this one also uses this queue to send a message. Look at the queue name. The queue name here is hello. The message is hello world. So it uses this name. You can only get this message through this hello. So this is why the receiving end is getting the message through this hello, which is the queue name. So that is basically RabbitMQ, and that is exactly what is happening here in Node.js. We only use strings as event names to listen to event. So a component can event emitters promote modularity by enabling components to communicate through events instead of tight coupling. So a company you can actually emit events to signal changes or request actions. So other companies can listen for these events and react accordingly. So creating a loosely coupled and reusable architecture. And RabbitMQ has other advanced techniques that you can, they have channels and all of that. You can send a message to channel, so only queues in that channel can actually get access to that message. And if you're interested, you can actually go ahead and then explore the docs. Worker queues, we have work queues, we have pub and sub, we have routing, and this where things get interested, where you route your messages, direct this, only this one will receive this message and all of that. So if you're interested in building microservices, then I guess you should learn RabbitMQ. Kafka is also good, but I prefer RabbitMQ. And then also for state management in simple applications, for like smaller applications, event emitters can be used for basic state management. Okay, it's like a central event emitter can store and manage application states. So UI components can listen for state change events and update themselves accordingly. Then custom events and notifications. So you can create custom event driven system for various purposes, like a file upload process might emit events for upload started, upload progress, and upload completed, allowing other parts of your application to track the upload status. And all of that, even a form validation process could emit events like for specific validation errors, and it can enable targeted error message in your UI and all of that. Obi, I guess you are listening to me. I said RabbitMQ is useful for task queues, used for building microservices. If you know what microservices are. If you don't know what microservices are, just you can go make some research. Later on, I may touch a little bit on microservices, but for now, just don't worry. You can get to understand what microservices are later, but for now, there are kind of different applications working together. The applications are, instead of using a monolithic architecture where your application is tightly coupled, you can distribute your applications to different services and then allow them to communicate together. So that is where RabbitMQ comes in. It serves as a message queue that if one of your server or one of your application triggers an event, then you allow the other service or other application that are working together to receive that service. And then let's assume you have the user service built with Python, and then you have the blog service built with JavaScript. So when the user logs in from the Python here, you want when the user logs in from the Python, the user is registered or is logged in. Then if a user creates a blog, you want to actually send an event to the blog service, which is built with JavaScript, with the user ID and then the blog, the content of the blog. So when the user creates a blog, the blog is being sent to the user ID so that that service with a different database will be able to store the user ID and the blog so that in subsequent retrievers, where a user want to retrieve his blog or other people want to read it, that blog will be retrieved from that database with user ID, knowing exactly who created the blog. But these are different services communicating to that. You can make your research on microservices and get to understand how they work. And then let's move on to the event emitter class. So you can actually inherit from the event emitter class and get to do things with it. You can do something like, let's assume we have import, you can say events emitter from node events like this. So this is actually a class or an object you can inherit from. You can say class, then you can say custom emitter is equal to extend in your event emitter class like this. This is how to inherit, it's not equal to just extend. This is how to inherit using classes. And then the event emitter class, it actually provides essential methods for managing events like the emit. This method triggers an event with a specified event name. You can actually optionally pass arguments as we've been passing on the other one. And then the on method, this method registers a listener function for a particular event. So the listener function will be called whenever the event is emitted. Then the once similar to on, but the listener function will be called only the first time the event is emitted and then automatically removed. The off method, this method removes the previously registered listener function for specific event name. So we have also remove all listener. This method removes all listener registered for a particular event name. Okay, let's say for instance now we've inherited from the emit, but we don't want to add any method here. We can simply do something like const my, you can say emitter is equal to new custom emitter. Now, if you hover over this, you have custom emitter, default event, and all of that. So if you hover over this one, event emitter, this, da, 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 da. If you hover over this one, it's inherited from this event emitter. So you can see emitter was okay, emitter emit. I want to emit an event. Let's just say event name is equal to message, like so. And I want to emit an event, and then you see the name of the event is event name. And then we have the message of message hello from emitter, like this, just as simple as this, hello from emitter. And then at the same time we want to listen to this event, and then we say emitter, this is our event name. We want to listen to this very event, and then we'll pass in a function of, let's say, data. We want to get access to the data that has been sent together with the event name. And then we'll say log data, like so. And then we can handle also errors. Then we can say something like emitter once. We can say event name error. This is an error we want to handle here. And then we'll take in this error argument in our callback function, like this. This is error. And in here, see, just log the error on the console in case any error occurs during the meeting event and all of this. So let's just check this out and see our code is working as expected. Okay, so I have message hello from emitter. So this is the data coming. We have our message here, which is an object. So this data, it's representing this whole object here. The data is representing this whole object. So you can say message is equal to data. Then you can get access to your message. If you only want to access the message, you can do this. You have your hello from emitter as a string. Then you can see console like message or split, like this. Then you have your array of characters in your message. Anyhow you want to do it, it's a string. You can use other method on it and then process it and save it to a database and do all of this. Anything you want to do. So beyond the built-in class, while the built-in event emitter class is widely used, there are also third-party libraries like event emitter 3, like I earlier mentioned. They offer additional features and enhancements such as types event or wildcard event listeners and all of that. Now, that is one of the third-party event emitter libraries. We have other event emitter library also. So like the event emitter 3, you can, let's assume the event emitter 3 can emit a message like, let's say this is something like this. Now, going forward, wildcard, this is a wildcard event listener. So it allows you to register listeners for events with patterns, e.g. so to listen to all user events. So this is, you can say, this one is to listen to all user events. Let's say we have an event of const event name is equal to, okay, event 2 is equal to, let's assume or instead of message, you can change this to user like this. And here we have user name. I just want to use user to clarify this. And then you can listen, since this is a user, if you specify here this event name, this can access the username or user name, it's something like this. We're using the event emitter 3, and this is what RabbitMQ also does. And these are enhanced event emitter third libraries. We also have event emitter 2, another popular library that extends the functionalities of the built-in event emitter with promise support, limited memory usage, and error handling, and all of that. So you can go check it out and get accustomed to it. Okay, so I guess this is all about event emitters, how you can emit events. Sorry, we don't have time to actually build a standard application with event emitter, like a chat application or a tool we can use event emitters for. I hope in building a basic application with Node.js and TypeScript, we get to have a feature that has to do with event emitter so we can understand it in depth. So moving forward, we have streams. So this one, event emitters are quite important, but most of you may be building server-side applications without using event emitters because they're used for real-time communication. But streams, you cannot build a server-side application without using streams. It is impossible. So let's get to understand what streams are. So streams are a fundamental concept in Node.js for handling data that arrives or is generated in a continuous flow. So in streams, you don't expect to have data that is 1 gig or 2 gig and you want to send it once. No, your application will crash. So you have to read that data, you have to send it in chunks, and then the receiving end will also receive it in chunks. Okay, just assume you have a text of about 1 MB or 2 MB and you want to send it once. No. So you have to use the on listener to say, just send the message in chunks and then receive it also and process it in chunks. So that maybe if you have 1 MB of data, you can be sending 1 kilobyte till you send everything. And then the receiving end will also be receiving 1 or 2 kilobytes till it receives everything instead of receiving all, which can lead to memory outage or all of that. So under streams, you have readable streams, writable streams, duplex streams. So the readable streams represent a source of data that emits chunks of data over time. So you imagine like a water pipe continuously flowing with water, something like that. And writable stream, they represent a destination for data that receives chunks of data and writes them to a specific location. Is it like a file or a network socket? So the readable streams, the readable streams, they read the data from the writable streams and all of that. So we also have the duplex streams. So they combine both readable and writable functionalities, allowing data to flow in both directions. And we also have a transform stream. This is a type of duplex stream that can modify or transform the data flowing through it as it's processed. And we also have stream events. So as we have event emitters are being coupled in streams. So streams emit events to signal their state and data flow. So common events include the data. It is emitted when a chunk of data is available to be read. And then the end, emitted when the readable stream finishes sending all the data. And the error, emitted if an error occurs during the stream operation. We also have stream pipelines and back pressure. So the stream pipelines, you can chain multiple streams together to create pipelines for processing data. So each stream in the pipeline performs an operation on the data before passing it to the next stream. And back pressure, what exactly is back pressure? Back pressure is a crucial concept when dealing with readable streams. So it's a kind of a mechanism that prevents a fast producer from overwhelming a slow consumer. That is the destination. The fast producer is the data source, and then the slower consumer is the data destination. So back pressure allows the consumer to signal the producer to slow down data flow. So that is where back pressure is important. It allows the consumer, that is the data destination, to signal the producer to slow down the data flow. So if you are sending data too fast, and I can't receive that data as fast as you are sending it, it will lead to data loss and all of that. So I will have to signal you to calm down, send it bit by bit so I can be able to receive everything. So moving on, we have the common stream types. While Nodejs provides built-in stream types for various use cases, including create read stream, create write stream, process that stdin. This process stdin reads data from the standard input stream, usually like a user input, then process std out, write data to the standard output stream, usually the console. And then we have incoming message, HTTP incoming message, which represents the readable stream for incoming data from an HTTP request. Yeah. And the HTTP server response. This also represents the writable stream from sending data back to the client in an HTTP response. And we have third-party stream libraries like stream and readable stream. So they offer additional functionalities. And if you don't want to go down implementing everything from scratch, you can actually use this. We also have async await with streams. You can use async await with streams, and we'll get to that in a bit. So let's start with the core concepts of streams. So we'll start with the readable stream. So a readable stream, let's imagine a data source like a file or a network connection that continuously generates data in chunks. So a readable stream represents this data source. It emits the data event whenever a new chunk of data is available to be read. So once you make available a new chunk of data, the readable stream will make it available to be read. And all these methods are chained on the file system, which is the FS. So we can get access to the FS here. You can say import FS from load FS. And then you can say const. It's a readable string is equal to FS create read stream like this. And then the path is, let's see if we have a file here. Okay, name.txt. I think we have a file of name.txt. We'll say name.txt like this. And whenever there's data in the name.txt, this event will be emitted. They will say readable stream dot on. They will say data. The data, and you can see all we have resume, ready, readable, pause, open, error, end, data, and close. But what we need is data, and then we have a callback function with the chunk that will be sent if it's available. And in here, we will want to say log chunk dot to string, and the default argument to the string this is curly braces, not square brackets. Another mistake. Okay, now let's execute our code. We have KodeCamp, Nodejs, all of that. So if we have a mechanism, like we have a server that is continuously running, anytime there's data in here, let's say we add another one, camp, this will automatically be emitted. But we don't have a server and we have to start this. Okay, let's say node. Let's not go into that. I wanted to implement a simple server that will show us how this thing works. So far as this is listening to the data event, anytime there's a change in this file, it will automatically be emitted. Now, if you pass here, if you pass in hexadecimal, you see that the data you get here is hexadecimal value. Now you can see ASCII or UTF-8, Indian UTF, whatsoever base 64. If you pass in base 64, you have your base 64 encoded string. But the default here is UTF-8. UTF-8. If you run this, you have your UTF-8. And if you remove this, it still defaults to UTF-8. And if you run it, you still have your human readable form of the chunk you've been processed. And in here, you can say log chunk. As you can see, this is a buffer. Now, the reason why I'm doing this, I want to introduce buffers to you. Now, go ahead and check the value of, let me see if I can detect. Okay, let's make a change to, okay. Okay, there's not much of a difference. You can import from FS. Import from FS and you still have your code running. But the advantage is it enhances readability and you are specific to this that, yes, this FS is coming from Node. It's a Node inbuilt module and it's not coming from somewhere else and all of that. But then you can head over to Nodejs. Okay, Nodejs, and then search Node FS. Okay, so Node FS. The file system plugs. Okay, we have some deprecated this thing. I just want to show you table of contents. I can't see, where can I see this? Okay, that's by the way, you can go there and search for it, but as I mentioned, readability and has some advantages as well. Okay, so now we have chunk and we have buffer. We can, and before we continue, let me quickly introduce buffers to you. You see, const name is equal to buffer dot from, then we say let's see, we have 4b 4b. Let's just copy what is here and then we explain it ASAP like this, and then you log name. Now clear this terminal here, then log this to the console. We have this buffer. So buffer is like an array in memory that holds data temporary before it is written to a disk or a file. So as you can see, we have, if you check your ASCII, let's check ASCII table. We have ASCII table. Okay, now we have our ASCII table. Oops. Let me zoom in this ASCII table. I just want to show you this ASCII table. Okay, ASCII table. Let me open this so we can see a clear image, and it's not opening. Oops. Should I just navigate to images so I can see the ASCII table? Click on this one here. And okay, should I visit this? Aha. We have our ASCII table. Now looking at this. Okay, I want to look for letters. We have 65. Look at we have decimal, octal, hexadecimal, and binary number system. So 0 in hexadecimal, binary, or anyway represent a null character. This is a start of a header, start of text, end of text for this. And then those are notes. I think you don't need to understand that for now. What we are looking for is, look at the numbers. We have 48 in decimal for 0 and 60. But then let's come back to our code. In our code here, we have 62. So what is 62? 62 here is, no. 62, 62, yes, is it hexadecimal? In hexadecimal, that is in base 16. In base 16, 62 here represents B. And 098 represents, and in octal number system, 62 represents, well, first of all, let's just check out what we have. Then we have name dot to string UTF-8. Let's leave it like that. And we have buffer. Okay. Now 62, as we earlier saw, represent B. We have our B here. 62 is B. And then we have U is 75. And F is 66. Now let's go back to our code. We have, oops, we have 75 and 66. So this is U. We have 66 twice, which is F, F, E, and R. So this is a hexadecimal number system. So you can, if you want to log this in hexadecimal format, you see that it will become a string, or we have 62, 75, 60, 66, and then we have 65, 72. So if you log it in hexadecimal number system, you see that this will be a string of this. We have 62, 75, and this 0x here represent hexadecimal number system. And then you can have 0, 0, 0, 0. This is octal number system, and the result will be quite different. This is the octal number system, and the result will be quite different. Now, if you log this to the console, this time around we're having 3, 2, and then let's change it to UTF-8 so we can see. We have 2 is equal to 665 colon what. So let's check the octal number system and see 2 and equal to what it represents in the ASCII table. So where is the octal number system? Are you sure we have, okay, octal. Now we have in octal 62 represent 2. And the equal sign, do we have equal sign here? The equal sign represents 75, 62, 75. Let's check our code. 62, 75 in the octal number system. So in the binary system, you can change this to B. Is it B? Binary, forgotten actually. Okay, that's these things here, this X here represent hexadecimal number system. If you see an O, it represents the octal number system. 0O, this is to tell the compiler that, oh, this is a hexadecimal number system, or this is basically the octal number system we're using here. So this, in this buffer, if you're changing this to a human readable form, just know that what we input here is a And then you can combine the hexadecimal and the octal number system here and then log it to the console. We have B is equal to 665 because B is buffer. And then if you change this to hexadecimal number system, you see that BU 665. So it depends on how you want to encode your data and all of that. So this is a buffer. That is the reason why some data is, if you want to transmit data, you store it in very secure form, so you can, after sending it, then you can convert it. So let's assume we have const buffer is equal to, and then let's say it's just an array of these things which we don't know. Then you can say const name is equal to buffer that's from, or let's say this is actually a buffer that's from buff. So here now you can just convert this to any form you want. We can even convert it to let's say base 64 and then store it. You've encoded this and no one knows what this is. So you can just leave it to UTF-8. If you want to read it and then show it to a human, make it a human readable form, you can just, this is a buffer. Okay, so these are buffers. Now in here, coming back to our code, what we have here is a buffer. This is this chunk. This chunk is actually encoded. So this thing converts this thing to a buffer and send it, and it's converted to UTF-60. Let's log this to the console again. And then we have this buffer. And to string, we have KodeCamp. K in capital is, we're seeing that 4B. What is 4B? 4B. 4B. 4B is capital K, as you can see it in octal, is it? In hexadecimal form, 4B is capital K. And then O, and if you check O, you see that the corresponding value of O is 6F in hexadecimal form. And then D is 64, because D is 64, 63 is C, 62 is B, and 61 is A, I guess. So that is it. Now, converting this is a buffer. As you can see, it's an array in memory that temporarily holds this data. And then you can convert it to human readable form. Okay, so this is basically it. Then you can convert it to hexadecimal to make it a single string in hexadecimal. Then you can have 4B6F. As you can see, this hexadecimal number is just the combination of it, changes this array buffer to strings. 4B6F 64 65. You can see 4B6F 64 65. So this, you can do different things with buffers and all of that. So this is coming in as a buffer, because buffer holds it holds the memory it holds the data in memory. It is written to a disk or processed. So this is basically holding our data as buffer. But here we'll say to string. If you say UTF-8, UTF-8 is the default, and then you can say ASCII. But UTF-8 is the extended version of ASCII. So some characters might get missing if you use we have KodeCamp, JavaScript. Okay, we don't have characters here that are not supported in ASCII. UTF-8 has some characters that ASCII doesn't support. So if you include them, you see a different result here. But UTF-8 is simply the superset of ASCII. So you can go check it out. Okay, so I guess we now understand. I never wanted to include buffers as a different topic, but I just want to introduce it to you so you can go check it out and understand how buffers work. So now I guess we understand buffers. Moving on, this is basically how we can create a readable string with the FS create read string with FS module. So the FS create read string, it creates a readable string from the data. This name, this is our data, the name txt file event. So we're using the data event. So whenever a chunk of data is available, the listener function is called with the data chunk as argument. Okay, so now we also have writable strings. So if you can read data, we can also write data. So basically, let's say we have, let's come to this file here, remove this, and then come down here, you can see this is fs create write string, and here we have our name txt like this, and our name, the txt, we see write string. Okay, this is writeable string. We say write, then we say write string dot write, and we say code camp. We say write string dot write, and in here we can see Nodejs. And then when we are done writing, we can say write string and see all data written, like so. And we want to also say when we are done writing, you can say write string on, then we call the end events to listen to this and see. We can see log. Okay, let's say data written successfully. Is it successfully? Okay, like this. Okay, now let's open this, and we have KodeCamp Nodejs, and we have all data written successfully. Then in here we can even say something, do something like this, so that all the data will be written on a separate line, and like this. Okay. So now if you open this, we have KodeCamp Nodejs and all data written. So what is simply going on here is this. Now, when the FS create write string, it creates a writable string for the output file test. So the write method is used to write data chunks to the string. So the end method indicates that no more data will be written. Finally, an end event listener is used to handle the successful completion of writing process. And we also have duplex streams. And in duplex streams, these versatile streams can both read and write data. So they combine the functionalities of reading and writing streams. So you can use the net, you can install this package, net. I'm not going to do it, but I just want to import net from net like this. Let me just bring it up here. Okay. Anthony, since you have a question, or is it the very one you typed? Your hand is raised. Okay. So what this fs create write string is, it's reading the path. You can see, you can even append this with this, and it's still the same thing. This is the path to the file. Now, if you open this, you still have your data. I can remove this data, save it, run this again. If you open this, you still have your data. So what create write string does is it reads the path to this file. And then when it gets the path to the file, it takes your data that you are writing, and then it will take the data, read the path to that file, get access to the file, and then write this content to this file. That's basically what it does. So like this is the same thing as this, because this it will still detect that the file is in the same directory. This name.txt file is in the same directory. But if in case we have, let's say we have another folder, let's say folder, we have a folder that is named. Now inside of that folder, we have the name txt. You can do something like this. Okay, so move out to this files folder and then locate the name txt inside of that folder. But since it is in the same directory with the index.js file, you just do something like this, and it is the same thing as doing like this. If you want it to be more clear, you can do like this. Okay, locate it in the same folder as this file. Okay, so that's basically it. Name txt. Okay, so now that we have this net package, it's a kind of provide, as you can see, node net modules. Okay, you can see something like node net or node fs. I wanted to skip this, but then let's see how we can demonstrate the duplex streams. So they combine the functionalities of reading and writing streams. So for instance, we have let's just say we have remove this. We don't need that. So we have const. So socket is equal to net create server. We first of all create a server, and this server will take a callback function of string with an argument of string. Then we say string on this. We have data, and this will also take this callback function with a data argument, which is equal to like this with the data argument. And then we say log receive data. Let's say received let's say data from clients like this. And then we can see data received from client and echoed. You can see log string, or let's just say string write data received from clients and code back. And we end this with a new line like this. So then we can listen to our server, but listen 8080 like this. So it's this example here creates a duplex string using a TCP socket server. So the server listens for incoming connections. When a client connects, a duplex string is established. So the server listens for data events on the string, reads data sent by the client, and then writes a response back to the client using same string. Now, if you run node index.js, okay, now if you hover over this, you get to understand that there's a callback function. You can pass in a callback function and say log server running. Stop this server and start it again, and we have server running because our server is now running. Now, if you try to connect to our server on port 8080 and then write data, I will leave this to you as an exercise. You can go try doing that by yourself. Try to our server on connect to this, implement this, connect to this server on port 8080. Let's say log data, and then try using like Postman or any tool you wish to connect to this server and then write data to this, and then you see what will happen here. And you can also, as this data is received, you can pipe this data and then write it to this name txt. Any data that is being sent from the network, you can pipe it and then write it to this name txt file. But I will leave that up to you. This is basically how to create a simple server that we can accept data streams from the network and then pipe it or they do whatsoever we want to do with it. And we have transform streams. These are special type of duplex string that can modify or transform the data flowing through them. So they provide a powerful way to process data on the fly within a stream pipeline. So transform streams, this is basically an introduction. You can get to understand the special form of these duplex streams and how to transform data. Maybe the data is coming, oh, if this data is a number, pipe this to, if it's an error, pipe it to the error console. If it's actual data, pipe it to the log method on the console. If it's an error, pipe it to the error method on the console, and all of that. So as we earlier looked at the read string, you can use the toString method to read buffers, and the end, you also look at the end method on the readable string we created earlier. I also looked at the error method. If there's an error, we can use that to handle the error. And we also have stream pipelines. There are powerful concepts in Nodejs that allow you to chain multiple streams together to create a data processing workflow. So each stream in the pipeline performs an operation on the data before passing it to the next stream. So this enables you to build complex data processing tasks in a modular and efficient way. So chaining streams, imagine a series of processing steps for data like reading a file, compressing it, and then writing it to another file. You can just achieve this using a stream pipeline. Okay, let's just see. Let's come up with an example. I hope it doesn't involve external libraries because I won't be installing any external library. Let's say import zlib. Is this an external library? Okay, let's say zlib. Okay. Let's quickly check it out. If it's an external library, zlib npm. This way we get to know if it's okay. It's an external library. Well, I guess Node.js also have zlib in version 22, the documentation. Zlib. Okay, I guess this should work. From Node zlib. Okay, thank God. They have an inbuilt zlib. So I will also need the fs. Import fs from Node fs, like so. And then we'll create a readable stream using fs create. Readable stream is equal to fs create read stream of name txt. And now we want to use the zlib to create a zip file. Let's say we have const gzip is equal to zlib dot create. Is it create gzip? Yeah, look at the method here. Create gzip. We'll call it like this to create a zip. And you can pass in options, but we're not interested in any options. And then read stream dot pipe gzip to, let's see, read stream dot pipe. And I'll explain this. Let me just pipe gzip dot pipe write writable stream. Also, we can create a writable stream. We did not create that like writable stream. You can say const writable stream is equal to fs create write stream of let's see, name dot txt. And you know that the extension for zipped files is gz like this. And then we want to pipe this to, and then we want to pipe it to the writable This one here is, the first pipe is to gzip, and the second pipe is to writable string, like so. Okay, so let's just stop this, our server that has been running for a while with no results, and then run our file once more. And then if you open here, I guess we should have a new, and now we have a new name. And if you open this file is not displaying text editor because it's a zip file. So what are we doing? So a read string, it reads the data.txt file, and then a writable string to write the compressed data to data.txt gz. So a transform string zip using zlib create to compress data on the fly. Can you understand what is happening? So when we read this data, we will zip it on the fly. We don't need to, once it is written, it will be zipped before it can be written. So what we do here, we read it, and then we pipe it to this one to zip it, and then we pipe it then to write it. That is the using of that is the use of pipe. This is being done on the run. So this is basically an example of chaining strings. We are chaining them. We first of all read it, and then we pipe it here so that we can create a gzip of the file. And then after that, we pipe it, then we write it to this very file here that is here. And you can also create, you can also unzip it and then do whatsoever you want to do. Then you can handle errors as well. You can come here and see, you can say gzip dot on error, and you can say writable string dot on error, and then readable string dot on error. You can handle all the errors while piping all of this and then changing the strings. You can do that as well. So benefits of string pipelines. And if you want this to be written to another folder, let's see, /zip /name. Then if you run this once more, then you have an error because there's no folder. But if you come here and create this folder here in this directory of, let's say, zip, and then we run our file once more. If you open this zip, you have this name.txt gzip inside. Now you have that to read this folder, read the file, and then write this inside. Okay, let's delete this. That's just an example. You can move it to trash and then leave this as it is. And now if you try to do it again. Now, if you handle errors, if you say gzip on error, see, you can take the error. I can throw new error of and error occurred like this. And then you can even add the error here if you wish to. Now this time around, let's do the same thing that we did. /zip /that, and then run this again. And this time around, we should do emitted error event on writing alert. Okay. Okay, there is no way the error is being, okay. It's writable string dot on. And just change this here to writable string to handle the error. Now, if you run this, you can see here, an error occurred. So when this is trying to write to this file, it does not find the folder, this folder zip. So it will throw an error. Oh, so the folder you're trying to write to does not exist. And this is the error. An error occurred, error. So after we log this, an error occurred. This is the error. We now display the error here to see what caused the actual error. So this is basically how to handle errors. So also back pressure. We talked about back pressure in event emitters. So back pressure is a crucial mechanism that prevents a faster producer from overwhelming a slower consumer, as I earlier said. So imagine you have a string that reads a large file very quickly. It's reading the file at 1 megabyte per second. And if the producer, okay, let's say it's very quickly another stream that writes data to that is a consumer. If the producer sends that data like 1 megabyte per second, faster than the consumer can consume, like the consumer is consuming 2 kilobytes per second. Now, two problems will occur here. Memory overload. So the consumer's buffer will fill up with the data chunks. It cannot process it yet, potentially leading to a memory leak or application crash. I told you earlier that buffers hold data in memory. So they will hold it and allow you to process it and write it or do whatever you want to do with it so that another buffer, when it gets filled, you will process the data and another data will come in. So by the time the consumer is slower than the producer, the data will get filled in the buffer and this will cause memory leak or application crash. Your application will definitely crash. And I mentioned data loss as well. If the buffer overflows, that is called buffer overflow. If there's too much data in a buffer and you are yet to process it, it causes buffer overflow. So new data chunks may be dropped, resulting in data loss. So if the buffer is overflowed, some chunks will be dropped, and then the new ones will fill up. The older ones will be dropped, and that is buffer, and then you lose the information. The earlier information that came in for the later one, you lose it. So this is where back pressure comes in. So when the consumer buffer reaches a certain threshold, so it signals the producer to slow down by pausing the stream. So this pauses prevents the producer from sending more data until the consumer has processed some of the existing data in the buffer and has space for more data to come. So what happens is a producer sends data, that is the producer stream. It emits chunks of data. So the consumer processes the data, the consumer stream receives the data in chunks and processes them. So if the buffer fills up, the consumer processes data, its internal buffer fills up the data chunks waiting to be written. So a higher watermark is reached. So when the buffer reaches a predefined higher watermark limit, the consumer emits a drain event. So the producer receives this drain event and pauses sending data. So once the consumer emits that drain, it's trying to tell the producer that, oh, calm down, slow down a bit, and get to finish processing the data in the buffer. So the producer receives the drain event and pauses sending data chunks. So the consumer writes the data already in the buffer. So the consumer continues processing the data in its buffer, freeing up space. So the buffer, once the buffer level falls below a lower watermark, the consumer might emit a resume event. So once the resume event is emitted, the producer receives the resume event and then starts sending data again. That is back pressure explained. So benefits of back pressure. You should take note of the new event, the drain, and the resume and what they are for. So the benefit of back pressure, it prevents memory leaks, prevents data loss, and it improves performance as well. So back pressure in practice, Node.js streams handle back pressure automatically. The writable stream implements the back pressure mechanism using the drain and optional resume event. In some cases, you might want to adjust the higher watermark or implement custom back pressure logic for specific scenarios if you wish to. The back pressure works best when both producer and consumer streams are, working together. And we have common stream types. The common stream types are the readable streams, which is the fs create read stream, and then you pass in the path to the file you want to create the read stream, and the process std, which represent the standard input stream. It's typically used for user input from the console, and the HTTP incoming message, a readable stream for incoming data from a HTTP request. All these three are under readable streams. That is fs create read stream, process std, and HTTP incoming message. They are all under readable streams. I guess I'll have to prepare some notes after the class, basically when I'm chanced. So we also have writable streams. They act as destination for data, receiving chunks of data and then writing them to a specific location, either to disk or to a file or elsewhere at all. And under writable streams, we have fs create stream, process std out, and HTTP server response. under duplex streams, we have the common streams here. They combine both readable and writable functionalities, which the net socket. Okay, bye you did. Don't worry about that. I will prepare both the notes for last week and this week's notes, and then drop it for you. I will update the repo today, but basically this night. Okay, so now we have the net socket. Okay, Anthony, there's something about learning. In learning, you don't actually really need to be taught everything. Some things you just find your way around it. What you need to do is try to practice, and you can head over to learn to read documentation. You can head over to Nodejs, read the docs, and then try to find simple applications that you can experiment with these simple things you've learned. So the main idea behind all these things, master the basics so you can build the complex stuff with those basics. So if you go around watching tutorials and doing all of that, if you go around watching tutorials and learning how to build complex things with those stuffs, you don't really understand. If you understand what those stuffs are doing under the hood, all you need is a concept. Once you understand the concept, you can go about implementing those features using those basics. It's just to build on top of them. So that's just the secret. When you understand the basics and you understand the problem, the solution automatically awaits you. I know the docs are boring, but that is where the real information lies. If you go to the docs and you don't understand, you can Google it somewhere. There may be a blog post that safely explains that concept. So when you read that blog post and you come back to the docs, you look at the docs, there are things in the docs that people don't normally explain. So when I'm looking for something that I really need to understand, I hop over to the docs. And if I don't understand it on the docs, I try to find a way to break that into simpler units and then try to consume it in order to understand what really the docs is trying to explain that I don't really understand. Okay, so that's by the way. I will try to provide resources for you on our Discord channel so you can go ahead and try to understand all these on your own. They are very, very important, especially streams and all of that. So under duplex streams, we have the net socket. It represents a TCP, a transfer control protocol socket connection, which can be used for both reading and writing data over a network, as I demonstrated earlier. And we have the TLS socket, similar to net socket, but provides secure communication using TLS, like secure SSL. Also have the transform streams, a special type of duplex stream that can modify or transfer the data flowing through it as it's processed. They are powerful for tasks like data encryption, compression, or filtering. As I mentioned earlier, we have the zlib create zip and the zlib create gunzip. So the create gunzip simply creates a transform stream for decompressing gzip compressed data. So we have other stream types like pass-through and deferred stream. So in Node.js, we have other additional stream types for like pass-through, which is a simple transform stream that passes data through without modification. And then the deferred stream, a writable stream that allows delaying the underlying destination until the stream is explicitly activated. So choosing the right stream depends on your project or what you want to do. And we have other third-party libraries like readable. You can find it out. You have stream true. We have true 2, which is a lightweight library for creating transform streams. We have Vinai. It's primarily used in building tools and task runners. Vinai provides the virtual file system abstraction for streams and all of that. And choosing the right library depends all on you. And there are so many things to all these things. The reason why sometimes I try to explain something in depth is for you to understand, because most of the times we face an interview and then fail. Someone will not hire, an employer will not hire someone who doesn't know what he or she is doing. So it's better you understand everything. If it's the concept, you understand the life cycle of that concept, you know exactly what you are doing. If you are using Express, why are you using Express? If you are using Nest.js, why are you using Nest.js? Sometimes you find yourself in a team where they use Express. Sometimes you find yourself in a team where they use Nest.js. That's perfectly fine, but then you have to understand the tool you are working in, because these are frameworks. I don't take Express as a framework because it provides you with like out of support this thing. You just have control. You have total control over it. So I don't consider it as a framework. To me, it's a mini library. Let me say a library framework, something like that. But Nest.js is a complete framework, and jumping into using frameworks, it's not quite advisable to me, because I really want to understand what those frameworks solve, what problem they solve, and why they're being used in the first place. So since we're going to be building on top of Nest.js, our next week we try to complete TypeScript and we understand TypeScript in depth. And then the next thing we'll do is we'll build a basic Node.js application. And if we have time, we will build this application from simple to advanced, production grade, and testing, where we have authentication and all of that, and we have all the streams implemented in all of this. So who asked this question? Is it Anthony or Anthony? Yes. So all of these things, some of them you find the answers when we start building a production grade app with just Node.js. Now, if you need an external library, it's because we will need it for a kind of a database, because I don't want to use JSON, because the data will persisted and then we'll host this application in production. So by that, you understand what problem Node.js solves and what problems Nest.js solves on top of Node.js. So for now, just chill, try to understand the basics as much as you can, so that when we get into real things, you will not be frustrated. And next week is for TypeScript. Those of you that find TypeScript frustrated, TypeScript will save you. It will save your life. It will reduce the stress for you. And there are many mistakes I've been making here, that if you use TypeScript, it has some static analysis that it will simply throw an error and they say, oh, what you're trying to do is wrong. This one first. And then JavaScript will not do that for you. And then you end up into, sometimes you forget, we're all human. Sometimes you forget, sometimes you simply don't recall. But that's just it. So I think we've come to the end of today's class. We've already mentioned control flow libraries. We talked about event emitters and streams. So what in our next class, we are done with Node.js code concept and all of that. We've learned promises, callbacks, and all of that. So the next thing we talk about is TypeScript. We learn TypeScript from basics to advanced, but we'll be quick about it. But I'll try to pinpoint things that if you want to reference them or if you want to check out the TypeScript docs, you will easily understand. So we're jumping on the main points that other concepts are built on top, because in our Node.js application, we'll be using TypeScript throughout the project, because Nest.js heavily use TypeScript. Okay, in absence of anything, we've come to the end of today's class.
I have a question to ask them.
Okay, you have a question? Okay, you can go ahead and ask.
Yeah,